Welcome back to Module 1. This is Lesson 9, and today we're talking about topologies, how networks are physically and logically shaped, and why that shape matters so much. Here's the idea I want you to carry through the whole lesson. Shape equals behavior. The way you design a network directly determines how it performs, how it fails, and how it recovers. Let's dive in. Before we look at specific shapes, there's an important distinction to make. Topology actually has two meanings. The physical topology is the literal wiring, where the cables run and where the devices sit. The logical topology is something different. It's the path the data actually takes through the network. And here's the catch. Those two views don't always match. A classic example is old Ethernet with hubs, physically wired as a star, but logically behaving like a bus, because every device shared the same signal path. With that distinction in mind, let's look at the four shapes you'll see again and again. Star is the workhorse of modern LANs. Every device homes back to a central switch, simple and easy to manage. Mesh connects everything to everything, giving you maximum redundancy at maximum cost, which is why you'll usually see it reserved for critical network cores. Bus and ring are mostly legacy now. A bus shares one backbone cable, which means one break takes everything down, while a ring loops each device to two neighbors and still shows up in some WAN technologies. The pattern to remember: Star wins for LANs. Mesh shows up where downtime simply isn't an option. Once you move beyond a single topology and start designing a whole enterprise network, Cisco's three-tier model is the blueprint you'll keep coming back to. At the bottom, the access layer is where users plug in: PC, phones, access points. Above that, distribution handles the thinking, routing between VLANs, applying policy, and aggregating all those access switches. And at the top, the core is pure speed, a backbone that just forwards traffic as fast as possible, no filtering, no slowdowns. In smaller networks, you'll often see core and distribution merged into a single collapsed core, but the roles themselves don't go away. Now, those layered designs live inside broader categories of networks, and it's worth knowing where each one fits. A LAN is everything inside a single site, your office or your home. A WAN stretches that reach, linking sites across cities or continents. Spine-leaf is the modern data center fabric, built for low, predictable latency between servers. And cloud, or SD-WAN, is where software takes over, managing services and wide area links over the internet. Spine-leaf and SD-WAN are the newer additions to the CCNA blueprint, so keep them on your radar. And that brings us to the end of this lesson on network topologies. Up next in Lesson 10, we'll shift from shapes to the actual hardware: hubs, switches, routers, and firewalls, and see how each device shapes the behavior we've been talking about. If this helped things click, hit subscribe and turn on notifications so you don't miss the next one. The full course is waiting for you on Dargslan.com. See you in the next lesson.